mean, that is 225. Fine. We have got the mean of these two variables, and this comes to be 30 and 25. Absolutely, these two means are the whole numbers. So here we must get an indication that a deviation form would be a comfortable option. So deviation form. Now, the moment we have decided that this sum should be solved with the deviation form of calculation, then we must define, let small x is x minus x bar, this is x minus 30, and the small y, that is y minus y bar, and this is y minus 25. So the both variables, when they are deviated from their own averages or the means, we are getting a small x and a small y. So this is a small x, and this is x minus 30, and this is a small y, that is capital Y minus 25, and now this is small x square, since we are dealing with the deviation form, small y square, and final column is small xy. So now the next step is we have to find the values of a small x and a small y, which will be used in the formula. And how a small x and a small y is to be found? We simply have to deviate each value of x from their own mean, that is 30, and a small y will be found by deviating each value of y from their own mean, 25, and the sum of these two columns according to the property of mean has to be 0. At the very outset I am telling this. This 0 is the sum of deviation from mean. These are the deviations, and when it will be summed up, it is sum. So this column is going to give us the sum of deviations from mean, and one of the property of mean is that the sum of deviation from mean is always 0. So the sum of these two columns has to be 0. Now let us find the value. Yes, minus 16 and plus 16. So absolutely it is 0. And here so negative is 7 plus 5 plus 3 plus 4, that is a minus 19, and 5 plus 4, 9 plus 2, 11 plus 4, 15. So this will be 2, yes, and so now yes, so minus 19 and plus 19, that comes out to 0, so that's all right. When you get the summation of these two columns as 0, then only you just proceed. Now you don't have to any relation with these two, original x and original y. Now we have to deal with these two columns. Now it has to be squared up. So x, each value of x, you get the square. So this is 49, 9, 4, 4, 4, 0, 0, 9, 25, and this is 64. The square of this column, this is 49, 25, 9, 4, 16, 16, 4, once again 16, 9 and 16. And the final column is, as per the required, is the very product of this x and a small x and a small y. So these two corresponding values of these two columns have to be multiplied. So this is minus 7 into minus 7. This is 15. This is 6. Minus 4. 8. 0, 0, 12, 15, and this is 32. these 4 columns, rather 3 columns, have to be added up. This is 168 and and 164, and here the lone number is negative. Positive is 137, minus 4 has to be subtracted, so this is 133. This is what the table work is required to be done, and now you just calculate. So Pearson's correlation coefficient is Rxy is covariance xy divided by standard deviation of x and standard deviation of y, and here deviation form has to be written, and summation xy by divided by summation x square into summation y square, where you may define x is x minus x bar and a small y is y minus y bar, no doubt anywhere. Now these 3 values have to be taken. This is 133 divided by under root 168 into 164. 168 into 164, and if this is solved, this will give you the value probably 0.82. 0.82, and this is what we may have the use of 0.82. A strong positive correlation, we can write a strong positive correlation between x and y. Here we have clearly seen that a sum has to be solved for the Pearson correlation coefficient. Initially we found the mean of both x and y as the whole numbers, and accordingly we used the non-deviation for this deviation form of Pearson. Now just I am going to solve another sum for non-deviation. There we shall see that when that form has to be used, because both are the similar derivations, originates from the same origin. No difference, mathematically no difference lies between those two. So, question is find Rxy